Hello everyone, this is Navya Vashni. This project is a real-time ETL pipeline built using PostgreSQL, Debizium, Apache Kafka, Python, DuckDB, FastAPI, React, Docker, and Docker Compose. The goal of the project is to capture database changes in a real time using change data capture, process those events through Kafka, apply business transformations, and load the transformed data into a DuckDB analytics warehouse. This solves the problem of traditional batch ETL systems where data becomes stale and updates are only available after scheduled jobs in a real world organizations such as banking, e commerce, fintech, and analytic platforms. Real time data processing is important for a monitoring and a decision making. The flow starts from PostgreSQL, where transaction records are stored. Debizium monitors Postgres write ahead logs and captures, insert updates, and deletes. These CDC events are published into Kafka topics. A Python consumer subscribers to Kafka process the events, applies transformations such as PII masking, currency conversion, and quarantine checks and SLA monitoring. The transformed data is stored in DuckDB. FastAPI exposes monitoring APIs and React dashboard displays pipeline health and freshness information. I selected this architecture because it follows a modern event-driven data engineering principles and supports a near real-time processing. The project contains multiple components. The Postgres folder contains the database initialization script. The Python consumer folder contains the Kafka consumer FastAPI endpoints transformation logic and Debizium connector registration. The React UI folder contains the monitoring dashboard. The scripts folder contains the seed data.py file for generating the initial dataset and the change simulator.py for generating continuous CDC events. Docker Compose orchestration all services together and manages startup dependencies and health checks. One of the most challenging part was configuring Debizium and PostgreSQL logical replication correctly. Another challenge was DuckDB file locking because multiple processes cannot write to the same DuckDB file simultaneously. I also faced issues with Kafka consumer offset management to avoid message loss. I implemented manual offset commits after successful processing. Handling malformed events and late arriving the events was another challenge. I solved this by implementing quarantine tables and exception handling so that bad records do not crash the pipeline. And the limitation and the feature improvements are currently currency conversion uses static exchange rates. This can be improved by integrating a live exchange rail service. The project currently provides at least once delivery semantics, exactly once processing can be implemented using a transactional Kafka consumers and transactional database rights. The dashboard is intentionally simple and can be extended with charts through throughput metrics and alerting system. The system can also be scaled further by running multiple Kafka consumer instances and partitioning topics. Overall, this project demonstrates a complete real-time CDC pipeline that captures database changes, streams them through Kafka, applies business transformations, stores analytical data in DuckDB, and provides monitoring through APIs and a React dashboard. This project helped me understand modern data engineering concepts such as CDC, event-driven architecture, stream processing, data quality management, SLA monitoring, and containerized deployments. Thank you.